Okay, so linear execution is when you have statement 1 in your program and statement 2 and so on. And statement 1 gets executed. Statement 1 gets executed before statement 2 and statement 2 gets executed before statement 3. This is the approach in almost every programming language, be it SQL, be it normal programming language, and everywhere. So there is a linear execution of the statements, right? Now, if we have the similar statements in pig, we say A equals to load, B equals to filter A, okay? B equals to filter A, C equals to group A, and D equals to dump C. Now, if you see this, the execution is not linear. Why? Because B will not get executed. When it executes D, it will execute C. It will execute A, but B will not get executed, right? So therefore, we call that the execution of syntax is non-linear in pig. Make sense to everyone? All right. So okay. So Puneet, let me say, when we say D equals to dump C, this will in case of pig, execution doesn't start now. Execution starts when somebody says D, dump, or somebody says not D, it will be like this, or store. Okay. So when you say dump, it will then compute it will then compute C, and to compute C it has to compute A, then it'll try to compute A. So you can see clearly that B has been skipped. Had it been a linear execution, first this will happen, then this will happen, then this will happen linearly. Murugan, does it make sense to you? Yeah, we are actually talking about pig only, Sham. All right. Yeah. So here, uh, Roshan's question is that are you saying the filter doesn't happen at all? So it doesn't. Okay. Because we are not talking about B anywhere. It just makes a note that hey, some you have said B equals to filter A, that's all. Why have that statement? It is up to you. We were talking about somebody writing code. Maybe at later point of time, if you say dump B, or if you say equals to grow order B by something, okay, and then you say dump E or store E, then it will execute B as well as E as well as B and then A. So it will say the order of execution when you say store E or dump E would look like execute A, then execute B, and then execute E. Here It'll be A. I'm putting dashes for commenting out things. It'll say A, then C. All right. So right now it is non-reachable, but it will not play because our, so we are actually, Sham, we are actually talking about right now pig. Hive is exactly what we have SQL. All right. So Santosh, I think I've answered your question. So we want, if we want filter to happen, you can apply filter in between. Okay. Yeah. Now Roshan's question is, so filter will play no role in making the group job easier for C. Not really, because C is not depending on B. Had C been depending on B, then filter will come into picture. Alright? If we had said here instead of A, we had said B, then it would matter. Now, okay. Now Santosh's question is, if we want to group on filtered values, we need to mention as this. That is perfect. That is correct. Alright? Does it make sense to you, Roshan? Great. So there's a one important thing about, and one big differentiator about pig. Sort of similar thing happens in case of SQL when you create views. You can create as many as views you want, but real execution of the query happens when you try to query from a view and or whenever you basically try to retrieve data from view, only then views will be doing the real execution. All right. So similar to this kind of non-linear workflow happens in case of views. Okay. In SQL, you generally have views, which is each view is basically representing a sort of a select query on a table. Okay. And then one view can create another view, so we can create another view on top of a view, and so on, right? So similar to that, similar, so most of the pig is like your uh, hives views or SQL's views. Okay, I'm talking about view as in VIEW in in SQL. So does it make sense? If how many of you have used views? Great. All right, no worries. Prithvi, if you haven't done. No, no, no. I mean to say, the pig, the way we created A equals to load file, A is kind of a view on top of this file. B is kind of a view on top of A, right? So that's how that's what I was trying to say. While in Hive there are both things. There are tables and there are views. We'll talk about it now. All right. So, Prithvi, I guess you are not aware of the views. So we'll talk about views briefly during Hive. So nothing to worry. All right. Great. Now let's start with our Hive. So where we were in Hive, I think we talked about the data types. The data types in Hive are sort of the okay, let me just go through very very quickly. So basically Hive is needed when you have code in SQL or people in SQL mainly, then you prefer to use Hive. But when you need a little bit more optimization, then you go for things like Pig. All right. It's good for because the queries take time. Queries are comparatively slower, and it doesn't provide you to record by manipulation. Then therefore you don't use Hive as really a SQL replacer. Instead, you use Hive more like an analytical engine, which you will be using only for querying the data. Now, this was the diagram. It has just like Pig. There is a driver which converts your queries into MapReduce. But this driver also depend on something called metastore. Metastore stores your metastore stores your data i- about table. What table are you trying to create? What are the columns in this table, and so on. Other difference between Pig and Hive is Pig you use in case your data is semi-structured or unstructured, while in case of Hive you first try to create a clearly structured data and then you feed it to Hive. Okay, so you can't really use Hive for converting a raw data into something in tabular format. All right. Now this we talked about. The quickest way to start Hive is by typing Hive. This way you get the command prompt and you can start using Hive. While if you want to execute just one command and then you want a Hive to exit, then you can use this way. If you have a bunch of commands written in a file, then you can run all of those in a single shot by using Hive-F, and you can do many kind of nice things with the command prompt of Hive, such as executing HDFS commands, and you can loading the once you have logged in into Hive and you are on that prompt, and then you realize, oh, there are some of my SQL commands lying in one file, and you want to execute all of them in a single shot, then you say source this. So yes, that is very correct, Santosh. So yes, you are right. Hive is used only for running a statistical report, not you. So Hive is generally used for running report, not only statistical, but all other kinds also. Okay. And is not usually for the cases when your job is write intensive. All right. Now comments start with dash dash. We talked about all of this. Okay. So get yourself acquainted with the Hive. Okay. How many of you tried after? So have you guys tried Pig? Great. So let me have a look. All right, so here we have, okay. So this subjective test you should definitely take. If there is any doubt in this subjective test, I mean, just drop me an email. There is two assignments with PIG. One is subjective test, other is objective. Finish both of them. Have a look at PIG UTF example, and that should give you fair amount of confidence in PIG. All right. Now we are here. Then the data types, as a general thumb rule to remember, Hive has all data types from all these languages. I mean Oracle SQL, MS SQL. So it has sort of a union of all the data types. All right. To unclutter your workspace, to separate out tables from one to another, it provides you a concept called database. You can keep on creating databases and keep using those databases and creating table inside those databases. All right, that should give you a lot of flexibility in terms of uh, uncluttering your workspace. All right. So concept of tables is exactly like your normal tables. And we talked about there are two kinds of tables. One is managed table, other is external table. The only thing you should keep in mind is when we talk about these tables, the difference between managed and external table is in managed table, when you drop a table, data gets deleted. In an external table, when you drop the table, the data does not get deleted. All right, that is the main difference. That is the main difference. All right. Now, Hive stores the metadata into database. That's called metastore. Okay. So unlike Pig, in Pig, when we say things like this, okay, we created A, B, C, and the moment we exited the prompt, the A, B, and C becomes meaningless, meaning there is no storage at all anywhere, right? But in case of Hive, in case you create a table on top, and whenever you are creating a table, the table metadata, as in what is the name of table, what is the name of the database, and what are the columns, what are their data types, all of this is counted as metadata and is stored in metastore. And this metastore is sort of a relational database. You can have a look at the relational database by doing something like MySQL. Here, all right, here you can see show databases, and there is automatically it has created a database. So this is MySQL, okay, and so show tables. I'll show you. So this is where the metadata is being stored by Hive. Okay, you can see things like TBLS. Okay, so I can say select star from So every table we create, it will create an entry here. You can see that it says that. So this is basically our other students' work where they have created the tables. So this data is stored as part of here. Okay, and you can see because we are creating a view. So when we create a view, metadata, I mean the Hive has to remember which query was it, right? And hence it has to store it somewhere. All right. Okay. So if you create your table, it will create an entry here in this database called metastore. Okay. So that is metastore. No, it's not replicated on other nodes. The Hive metastore is only a single node system. Yeah. Because it only stores the metadata information. It does not need to be so overloaded. No, internal and external tables are both same kind of table, just that when you delete internal table, the data which is stored gets deleted. Okay, that's the only difference. Both are just like tables. So any table you create in Hive, the data is generally on HDFS. Okay, the data is generally on HDFS. I'll show you a few examples. So Shyam's question is, so in both the cases, query is stored in metastore. Yes. So yeah. So in both the cases, query is not stored in database. It's only in the views. There is a third kind of thing called view. Okay, which says that create this table by executing this query on that table. Okay. So a definition of view in when we look at the view, it always remembers what is the query it needs to execute before giving you the data. Okay. All right. So anyway, I think I should give a little overview of what is a view before I use it. So let's say you have a table T. It has column A and column B. It has say one row and we have one and it has another row two. Now you want to create a table view on table. Okay, select create view vt. Okay, select star from t where a equals 1 or a greater than 2. Okay, this is not exact syntax, but for the simplicity I'm trying to show that. So we basically created a view here. Now, alright, if we do things like select star from T into T1, right? They will do exactly select star from T where this. Okay. Now VT and T1 are almost similar in nature right now. Both will have, what will VT have? Anybody? What will VT have? If you do select star from VT, what you will get? You'll get 2 and 2. Perfect. Right? Now what will this result? It's the same, right? Perfect. Now let's say after a point of time we insert into T, we insert 3 into 3 into T. Now the same queries, will they have the same answer or different answer? Right. So Prithvi, are you with me? Okay. So now here it will give 2 and 2 while it will give 2 and 3. So that's the difference between sorry, select star from VT. I'm sorry. It should have been this way, 3 and 2. Okay. Let me change the window size. Right. So do you understand the difference between a view and a table now? Oh, sorry. Last statement is should be T1. Okay, select star from T1. You are right. It should be something of this. Yeah, correct, Chandra. Thank you. Is everybody on the same page? I am trying to demonstrate the difference between a view and a table. So every time we do T1, it will be going back and trying to execute this query. And whatever this query depends on further, had your T been a view, again it will be triggering another set of map reduces. So every query will get converted into map reduce. So things like this will trigger map reduces and do your work. All right. So that was the difference between a view and a table. Okay. All right. Now let's say we had a file. We want to create a table like NYSC daily. Okay. And we are saying here, so till here we discussed last time, I think. This we were supposed to discuss today. Okay. So in case of Hive, what you do is you say create table NYSC daily, and till here it should be very clear to you that we are trying to create NYSE daily with exchange one as one column, symbol as another column, and so on. All right. So we are trying to create a table, and this is little newer syntax. Here I say that this is the file we are going to read. This is the file that represents our table, and the format of the file is the fields are terminated by slash t. Okay, which means our file is tab separated. We want to create a table on top of this data. Okay, if this data is already existing, then it will not create a new file, it will start using the same one. If it is not, if it is existing, then it starts using the same one. It's not existing, then the moment you insert data into this table, this this file will get created. This file will be created on HDFS. Okay, let me try to show you. Let's first create a database for this one. Let's go to Hive. Let's see how is our cluster doing. So something is down in Hive. It's a Hive server, although it's not required right now, but let's just again start. Hive server is required when you want to serve data to the end user. All right. Now serve the data via a JDBC driver directly from your server. All right. So now we have this table. We just created a table. Let's say what we say. It says the table already exists. So what we say is create database, and we say 21 fab, and we say 21 fab use, and then we create our table. Right now, let's see what is there. NYSE daily. Okay. So since that file already existed, that is the reason why the data is already there. Okay, that file was existed because there is another table already created on that file. Okay, so multiple tables can point to the same data. Okay, now in case, let me just drop this. So if I drop this, and also at the parallel time, you should see in the HDFS, in HDFS, does this file really exist? Does slash data slash NYSE daily really exist? Let's have a look at it. Okay, so let's go to the top level one. Let's go to a folder called data, and in this there is NYSE daily. You can see that. That's a folder. So the whole folder is a table, and this is our actual data. Sounds good to you? Now imagine this. What we want to do is let's drop this table. Okay, let's drop this table. So what will happen when we drop this table? Drop table this. What will happen? Will this file disappear? This is that file which is containing this table's data. Yes. So it will delete the table. That's correct. The data underlying this file. So when we say this is our table and this is the location of our data, all right, so this data will also get deleted. So the folder itself got deleted. You can see that it no longer exists. All right, so that is a managed table. So whenever you are creating a managed table, there are two things happening. First, your metadata about this table is going to be created in MySQL. Okay, the meta store. So that's very good question, Chandra. Chandra's question is, what if there are two tables on the same table? Now, as a matter of fact, it is. All right. Let's say we say use default, right? And you will see select star from NYSE daily. There is a table already existing. If I say describe formatted NYSE daily just to see what is there inside this table. So there is a table already created in previous sessions using the same command. So their data is also deleted. Now you can see the data is empty. All right. And the moment once say we again go to our database, what was our database? 21.5 fab, right? And we create this table. Now this table is going to be empty. Yes, you can restrict. So this way now it is created. Now let's load it. I will answer your question. That's a very good set of questions. Okay. Now if you remember that locally we had created a folder containing in the earlier session. Let me just open up another shell. So on one we will keep hive open, on another we will just keep command prompt open. Alright, now we go into Asgiri, we go into data, we go into hive. So here there is our file locally. Now this time what we are trying to do is we are trying to create a fresh table called NYSE daily, and we want to load the data into it. Okay, our data is say located on this local file, right? Home student, this one. So we'll say we want to load this data into hive. What we do is we say home, uh, we say load data local. Remember this local. Local means our file is local, not on HDFS. If we don't use this, then hive will try to find this file in HDFS. Okay, now have a look at this. Okay, now it has started loading the data. It has started loading the data. Now you can see select star from NYSE daily, and you can see the data has been loaded. Sounds good to you? And also few things I forgot to show you. Okay, let me just do it again. So here, this is what I did. Here I did load my file, this local file into NYSE daily and overwrite. I've written overwrite here, meaning the older data will get overwritten by this. All right. Right. So, okay. So now let me answer your questions. First one was from Chandra. Now, if you see, if I go into default database, and if you see that data over there in that table, you will see that that table is also containing the data now. So both the tables are basically pointing to the data located at the same HDFS location. Okay. All right. So whenever we create a table in Hive, there are two parts to it. One, location where the data is there, and second, the definition of table. This goes into Metastore while the data stays on the HDFS. Okay. So whenever we will be saying select star from NYSE daily, what will it do is first it will load the metadata from the Metastore, which is in MySQL, understand all the columns which are there, then understand how the data, how the fields are terminated like this, and afterwards it tries to understand what is there in that file based on these fields. Okay. Now Chandra's question was, this is scary. There were two different tables pointing to the same data location and deleting and reading from the same file. How can we restrict the users from fiddling around with each other's file? You can actually very easily do that. You in here there is a very clear way by in the Hive to give the privileges. Okay, like for example, here the everything that is being created in HDFS is on your behalf. It is created as a student. Okay. But if different users are using Hive from different accounts, then they will not be able to access the data that gets created under the hood will be under your privilege, and and therefore the data will be fairly separated. Okay. So one user will not be able to fiddle around with other users database. Okay. So let me show you another use case, another way. As in, let's say there is a root. So is there another user? I don't think so. Okay, right now we don't have any other user. I could have. Let's see if root is anyway administrator, so it can see everybody's data. And okay, so here we can see all the databases, and if I say create root db, create database, and use root db, yeah, so by default they are able to read. All right. Now the question is that, yeah, so using Hive itself, you can give permissions here. Okay. You can provide permissions to users on how to give basically separate out one database from another and so on. Okay. right? Morgan's point is that in this case, even hive table is like a view. So yes, you can look at it that way also. Every hive table is essentially a window over the actual data stored in HDFS. Okay. So if the node running Hive goes down, we lose all the metadata as no replication available. Yes. So if this running a node which is running the meta store, which is MySQL in our case, in case this node goes down, will not be able to query Hive. Okay. Sham was asking a question saying, all right. So yeah, logical grouping as I showed you is there. Okay. So by default, all the users have the same privileges. They can use each other's database, but you can give the permission on Hive so that one user cannot access other users' database. Also, the the data that gets created using Hive has different HDFS permission, and one user will not be able to access the data of another user. Okay. So, Chandra, was I able to answer your question? Even if we are running one more Hive instance in another node, actually the meta store is not yet load balanced. All right. Okay. No questions right now? Let's go ahead. All right. So we created a managed table, loaded data into it, and then queried this data. How do we distinguish the managed table from external table? What you do is you can see, let's say show tables. Okay. What you can do is you can say describe formatted this. Okay. All right. So Murugan's point is that Hive looks like a high risk for production environment, but if you separate out users' permission, it will not be that big a risk. If you provide separate different users, different account in HDFS and Hive, then it'll be completely okay. All right. Okay. Any chances of high traffic hitting Hive server? So there are chances, yes, that is correct. So generally what you do is in your say report engine, for example, in your report engine, you will be creating lot of queries, and uh, basically those queries will be coming to Hive server, and Hive server will be creating map reduces out of those queries and sending it to the network, right? Now Important part to note is unlike the usual database servers, Hive server does nothing. It just asks it just asks the Hadoop to execute MapReduces. That's all. Okay. It takes your query, converts it into MapReduce, sends it to Hadoop, and let Hadoop do the actual churning. Okay. So the role of our Hive server is fairly low. So next question is, so Sam's point is that I said that Hive is not suitable for OLTP. Isn't that statement true for most of the Hadoop's component? So when we talk about Hive or Pig, both of them have the same characteristic. But the system like HBase is fairly suitable for online transaction processing. Okay, I mean not transaction wise, but speed wise, HBase is fairly suitable for manipulating data at a very high frequency. Okay, so HBase is one which can actually handle a lot of requests in parallel without so much of delay. Okay, so I hope, yeah. What are the different options to load a table? I mean, load the table from the file system. Right now, it was just tab separated, but we'll talk about it quickly. Okay, so what are the different options? That is very correct, Morgan. Morgan says that, in my view, it is suitable for real-time transaction-based systems. However, it can be used for for analytics for the same historical data. That is very correct. So it's good for analytics on a humongous historical data, but not great when it comes to serving the users in real time. When I say it means Hive or Pig, because both of these, Hive or Pig, are going to convert your code into MapReduce, and then it'll go with the same latency as MapReduce. So MapReduce was designed with the mindset that it will be useful for humongous data, but in batch-wise processing. In case of Hadoop, the focus of execution is on distributed rather than getting it done right away by the use of memory or other means. So the main focus is generally on the distributed because the data is humongous. That is why MapReduce has been fairly slow. All right. So right now we loaded a file from local, meaning not from HDFS. So that file was first copied to HDFS and then put into that particular folder of our table /data/nysc daily. Now you might say that this is a royal waste of space. In case our file was existing on HDFS and our file is 100 GB, what is the point of cloning so much of data? Okay, will be every time we'll be loading the data into table, it will create another copy, then it will be royal waste of our space. Every time we do that, it will basically, if it tries to copy it, it will be too much of disk space wastage. And you can also think that if there are replication factor of 3, so and your file was 20 GB, so total size it's occupying is 60 GB. Now if we load that file into this table, it will again consume 60 more GB, which means 120 GB, right? Out of out of 20 GB, we are actually taking a space of 120 GB, and that is the reason why if we try to load the data from HDFS, it moves rather than copying the data, it moves. So just now when we did when we loaded the data from local file system, it copied to HDFS. In case had our file been in HDFS, data would basically move to slash data NYSE daily folder. All right, now let's have a look at this. These are the important things to remember. Now let's copy this file, whatever we loaded last time. Let's copy it into HDFS. Okay, I'm going to the command prompt and we are saying copy from local that particular file into sgiri. Now we have that file in sgiri folder. You can have a look. Hadoop fs sgiri now. So we just copied the last file to HDFS. So you can see here, this NYSE daily is what we have just copied. All right. Now, in case we say load data, this time we are not saying the keyword like local. Okay. Now, this will try to locate this data. Okay. In the HDFS, it will say, it will try to find this location in HDFS. It says load data in path asgiri slash NYSE daily, override into this table. Okay, overwrite means existing data will be overwritten in the table. Okay, now did I make a mistake here? Let me just see. Okay, so our data is in what? So the default location is this. Under this as Giri and NYSE. So this is, so I'm trying to load the data from, okay, we have to use your database. All right, now you can see that the data has been moved here. It says moved. Okay, first it deleted that file into trash and then put it. Okay, now you can see this. here. And where is our so I was trying to show you that if you go into this folder, that NYSE daily has disappeared from here. That file has disappeared from here. The file which we saw earlier is no longer there. Yeah, but the data has been there in this folder. So we can say select star from NYSE daily. It's there. So what am I trying to demonstrate to you? That when we loaded the data from local directory, it loaded it successfully. While we loaded it from the HDFS, it earlier it copied the data, now it just moved the data from one location to another. All right, makes sense to you? Yes, it will load all the files in that folder. Provided, I mean, it will try to parse it. If it is not, then it will skip that data and give. Alright, so Morgan's question is, in my view, it is not suitable for real-time transaction-based systems. However, it can be. Yeah, that is correct. I think, yeah, we have already discussed that part there. And since we are giving it a local directory, if we have multiple files, will it load all the files? That is Chandra's question. Yes, it will load. Okay. And by default, if you do not specify things like this, it instead of tab, it will by default take control A. Okay. And that's a general definition. All right. And in case this table is fresh, as soon as you load the data, that folder and everything will be created where the data is going to go. All right, sounds good to you? If we create another table using the same file in HDFS, will it create another data set? So if first is you'll have to copy that file in the HDFS because it tends to keep the same data and both the places. It will basically, as soon as you load the data, it will move the data to the location of the table we are talking about. Now, Prithvi's question is, if we create another table using the same file in HDS, will, yes, you can create the say another table using the same file. It will not copy the data. Yes. So Chandra's next question is, we created the table, our data got moved. Now, is it possible to retrieve it? Yes. So the data will basically go into this folder. Okay. There will be no change in the format of your files. They will just move into this folder. Whatever we defined while creating the table. All right. So Prithvi, was I able to answer? Okay. Now Prithvi's point is, say we have two tables, T1 and T2 with the same data. If we delete the data from T1, does it delete from T2? Yes, it does delete from T2. If both the tables T1 and T2 have the same location, all right? If both have same location and you drop the data, then the data from both the places disappears. That's what we tried to show you earlier. Okay, so the important thing to remember in these scenarios is, in case both the tables are managed, which means if either of the table is deleted, the data will disappear. So in these scenarios, when you are pointing to somebody else's table, you create external tables so that when you drop your table, the data should not get deleted. Make sense to you? Make sense to you? So if we have two tables having same data, make sure that either both of them are external or one of them is external, so that one guy deletes the data, it should not disappear for other guy. Okay. How to update additional data into data file, which is, so you basically say load again without this keyword called overwrite. If I don't use this overwrite, you will see that right now how many records are there. Okay, let me see. This one is going to take a little bit more time because this one will trigger MapReduce. So if you don't use a keyword called up overwrite here, it will add these many records again to the table. Is that what you're looking for? Yeah, we cannot simply do things like insert into this. Okay, insert this record, that record. No, we can only, in bulk, just take this data, dump it there. Yeah. Okay, so say these are these many records, 57,000 records right now, and what we want to do is, let's say we load the data again. Okay, and this time we don't say overwrite. Okay, now if you see, the count star from NYSE daily would be doubled. Earlier it was something like 57,000. You can see the tracking URL, the map and reduce which is happening. It has to be all or nothing. That is the better way to say. Thank you, Santosh. And yeah, you can see that number of records have doubled. All right. So all or nothing means that is the correct way of saying, because it doesn't let you manipulate single records, few records, add more records. Those kind of things it doesn't let you do. But you should note few things here. We loaded the data twice into this folder. Now let's see what has happened to our folder. Okay, let's see what has happened there. So this is the table which we are manipulating. So there are two files in this folder now. Okay, this one was the old one, this one is the new one. All right, so the data has got doubled. All right, so this is called loading of the data. So both are 3 MB each. Why does this surprise you, Morgan? Because we loaded the data twice. And in the second time, we did not say overwrite. So instead of overwriting, it basically created one more file. Let me make it single. Drop table this. And we can say, let me just load the table again because we have deleted it for demonstration purposes. Yeah, right. So it's basically you have two copies. It's basically folder that represents your table and all the data inside it. When you run select star from NYSE daily, it will get the data from first one. It'll get data from second one and present to you. Okay. The map reduce will consume all the folders, all the files inside this folder. Perfect. Now the purpose of loading file and doing all of this is the query. These kind of queries can simply go through the whole thousands of terabyte of data and give you the results using MapReduce cluster. So select star from NYSE daily where a record is equal to something. Now you can see that as a next step, we did what we did was we did a filtering. You see, we said, get me the details about a stock called CMC. Now we got those things in filter. All right. Similarly, if you want to say order by something, we can say easily, okay, we can say very comfortably things like order by YMD. Okay. We did not have to write any map or reduce or anything. Only these standard SQL queries gave us the result we required. Santos's question is there a concept of temporary table in Hive? So not yet. The temporary table concept is not there yet. If you need temporary table, you'll have to create your own. All right. So you can anyway create a separate table and start working. The benefit of temporary table in case of MS SQL or any other database was as soon as your session ends, the table gets deleted. The TMP table gets deleted. The other benefit of temporary table was to keep there was one kind of table which was in-memory table that gave us faster results. Okay, that we would not like to do in case of Hive because most of the data we will be churning will be of high magnitude. Okay, now yes, they do allow subqueries. Yeah, but instead of subqueries, try to create views that will make your life simple. All right. Now, in case you do not specify where is your data going to go, if we do not specify this location, automatically the data is saved here, saved in this folder. Okay, your data goes in this particular folder. In case you don't specify that this is my table. Okay, Now also here you can see that there is a folder for this is what we created today. This is a folder for each databases. You can see that by default in the warehouse, this will be the folder. In case you do not specify, so let's say we went here, we say create this and create this, and let's give it a different name. Okay. So if you don't specify where is the data going to go, it will go into this folder. Okay. Into here. Okay. So anybody else interested in seeing the data in MySQL? So whatever tables we are creating here, okay, these tables are this data is getting generated in MySQL because Hive is trying to store all the table definition in the meta store. Hive is storing all the metadata in the meta store. Metadata includes definition of table and other things. Now let's try to show you where is our MySQL. Say MySQL user. Okay. Now we say use Hive and we say select star from TBLS. So there, let's just, you can see NYSE daily access, right? So it has been created in the database. All right. Make sense to you? So, so this is our table which we created. There is another table containing more details about this. You can see there are so many tables. Some will be column privileges, table privilege. All of this information is stored in these tables. Okay. So the data you are looking for may be located somewhere which I don't know. Okay. But the idea was to let you know that the information about metadata is actually going to store in a relational database. Sounds good to you? Okay, there are so many tables and it will be spread across. Perfect. All right. Now you can do various kinds of things into the data, okay, on top of data, such as once you have queried the data, you can store it somewhere. And how can you store? You can say insert into local directory and say this, or insert override directory this. If you specify local directory, it will bring the data to local file system. If you say you do not say local, it will basically save this on the file system of HDFS. All right. If users want to query, do they have to log into Linux? Not really. Not really. They can query by connecting their, say, you have a SQL client. You can connect the SQL client directly to a Hive server, all right, and then start giving queries. Or they can use Hue to execute queries. Sounds good? Let's take a break of 10 minutes. Great. Okay. Let's take a break of 10 minutes. Back by 9:44. Hi, I'm back. So thank you, Morgan. Happy Ugadi to all of the people who celebrate. And all right, so should we start now? Is everybody back? All right, so great. So we talked about general mechanics, about Hive, about Metastore, HDFS. Okay. Now, apart from giving things like indexes, Hive gave us the ability to do the partitions. To avoid the full file scan, it gives you the partial scan part. We'll talk about partitions more. And data is stored in different files based on various combinations of columns. All right. So we create a table. We create a table, load part of the data from one place, load part of the data into another place, and we define them as partitions of a table. Okay. So I will talk about indexes also in the last. They have started working on indexes which look more like only for sorting purposes. I will show you a few examples. All right. Now you have to define partitions using a partition by in create table itself. All right. And so let's say that there was a file, the employee, containing these three columns. We have these three columns with two rows. That's and comma is the separator. So what we did was we created a table called employees and partitioned it by one fourth column called qualification and told that this is separated by comma. All right. Now, as we load data from this file into the employees, and we can say that this particular load of the data has to belong to a partition called qualification equals to 1. All right. Now second one belongs to qualification equals 2, right? And so on. Now, when we say select star from employees without any filter, it will give us the data from both the places, the AMP and the AMP1. Okay, so qualification, that's what I want here. Qualification is a partition column. It's an extra column. It's an extra column defined as part of the partition. Yes, it can be anything. We could say qualification 1, or we can say the age group. You can say age group, or we can say anything we want. All right. And now let's try to run through this. So let me go to my folder called, this is my Hive. Let's just get out of the MySQL. So this is what table. This is my folder called Asgiri Hive. Here we have two files locally, the AMP and the AMP1. The difference is in the second column, you can see, and that's all, nothing much. All right. Or you can further change few things. I'll just put 111 everywhere. Okay. So I can say here, so let's say just a minor differences are okay. Now we have the amp1 and the amp. All right. Now these two files, let's load it as two separate partition. Okay. So whenever we are creating partition, we are basically saying that in this partition, create a partition with this name, put all these records into that partition. Put all the records from, okay, so we have these two files. Let me create the table first. We are saying create this table, which is partitioned by a column called qualification, and fields are terminated by comma. As you can see that our files are comma separated. Now, what we do is, okay, so show tables gives us this one. So employees contain, right now, the employees do not contain anything. Select star from employees do not contain anything as of now. All right. Now, also you should note that so it's to see the details of employees as we discussed last time. You can say describe formatted. So in well formatted format, it tells you what are the column names. It also tells you the partition information. It says that partition is only based on one extra column called qualification. We could add more extra partition columns. All right. And the location of our data is going to be in the warehouse, inside our database namespace, and inside this employees folder. Okay. It's a managed table, and the default serializer deserializer, we'll talk about it. The way it is going to interpret our data is based on this. Okay. The way we has input is split, similarly there is these things, right? Input format is text input format. Okay, internally it's using the similar kind of input is split, and this is our output format. All right. Now Roshan, I'll give you answer your question in a minute. All right, no worries. And quickly you can also check out what exactly is going on with this folder. Not this way. Uh, not this way. We have to do a little bit different. So 21 fab.db warehouse, right? Okay. Right now there is nothing, just the folder has been created. The next step would be to start loading the data. So the amp, which was this, if we load it from local folder and we mark it as qualification 1, so what will actually happen? Let's see. Okay. Now if you say select star from employees, you will see that there are four columns. Three columns from our file. Fourth column is the qualification. Okay. The qualification. So it's sort of a pseudo index. If you see, it's sort of a pseudo index. And now if we try to do the second one, let's try to do the second one where we are loading another file into here. Now going back to the location which we talked about here, Now you will see that there are two separate files. Under employees table, under employees folder in the HDFS, the actual data is stored like this. Qualification equals 1, qualification equals 2. Alright. So few things. We copied the data. We copied the data. It automatically created. Now look at this. Select star from employees. You got 4 rows. 2 belong to the first partition, meaning 2 are kept in one file. Second 2 are kept in another file. Alright. Now, if you do things like select employees where qualification equals 1. Now, in this kind of queries, it does not have to read the second file. Okay, it does not unnecessarily have to open the second file and try to read it. Instead, only the first file will suffice. Okay, so this way the partitions can help you to a very large extent. But if you say things like select star from employees where name equals Sandeep, and in these cases it cannot do anything but scan both the files. Okay, so meaning when you are querying this table based on the partition column, then your the rate at which I mean it will be far more faster, because it has just to jump to that particular file, then quickly read that data. Okay, in this case, when your filter is not based on partition, then it has to create MapReduce and scan the data. All right. Partition information is also stored in metadata table. Metadata store. Okay, meta store. That is correct, Prithvi. Now, Roshan, is your question answered? How do we know which row record goes to which partition? Okay, you know clearly. So here, unlike the expected, where we think that we will dump the data into table and database will partition for us, it doesn't happen that way. Instead, you create the partition, you insert the data into a partition manually. Okay, one at a time. All right, now great. So this is what is called horizontal partitioning. Okay, the concept is not new. Concept has been practiced by various DBAs of various databases for quite some time. When the time came to handle lot of data, uh, these databases started giving you this feature of partitioning. Okay, all right. So even massive amount of data can be handled using Hive, be it 100 terabytes. If your table expands to say 500 terabytes, still Hive will be able to query that kind of table and run queries on top of that table. Right. So Prithvi's question is, can we write an expression on which the partition takes place, like partition by year? Yeah. So you can always write things like, you cannot say partition by qualification greater than 2. Okay. Here it has to be equal. Okay. Now I'll show you a few things. Again, here you have a look at this. So if you have, let's say, two columns, here let's say you are saying gender equals male, okay, and gender equals female. Okay, this way you can create four. If there are two qualifications and two genders, the total number of partitions will be four. You'll be creating total number of partitions. So you'll be creating the folder name exactly like this. All right. So that does it make sense to you? No. So you might question that what is the benefit of this thing? Why are we using this partition? So if I have a file with unsorted date, how do I load the data? Okay. So basically you load the data as is into Hive, and after you have uh, created the table, you can create the part. You can basically take the data from this file again and again and create multiple separate files. Okay, select star from this into this, select star from this into this, and that kind of thing. Okay, so basically what you do is you have a humongous file. Imagine this. You have a huge file. Yes. All right. Morgan's point is another example would be could be data partition based on reasons, etc. That is correct. Chandra's point is there a reason you are using columns in partition scheme that are not in actual file? Which one are we talking about? So here it's the same column name. So here that qualification is not there, but we are adding one more column. Whenever we say partition by this comma that, you are virtually adding those many columns. Okay. So if you add one more here, you say gender. You say gender as say bit. Okay. Or gender say boolean. Then you will basically, yeah. So basically, by creating a partition, you essentially are adding those many columns into the data. So by adding one partition here, we added one more column called qualification to our table. As you can see, we we can see that select star from employees will have four columns. You can see, all right. While the actual data only has three columns. Now you can see more detail about this table: describe, formatted, and employees. Here, describe, describe. Okay. Here you will see that there are only three columns. Fourth column is a partition column. Okay. Make sense to you, Chandra? No? Your question was different. All right, good. Okay, so I hope that is clear to you. Now let me answer. There was one more question. Can you explain the unsorted data? Yeah. So basically, the right now, With respect to unsorted data, the let me go through the question. Before that, there is no other question. Let me. Okay, so let me copy. So the voice starts breaking exactly at 10 o'clock. Hello. So let me just disconnect my earphone and connect it again. Hello. Yeah, can you hear me clearly? All right. And also, do you see any delay in the UI? If you see the delay, we will try to do something. But last time, what we did was we actually um, stopped the recording, started it again, so the delay went away. But there was some problem with respect to recording that had happened after midway. Is my voice still breaking? Okay, good, good. All right, so now let's go ahead. So I was trying to go through your questions. So, okay, this is answered. Now, can you please explain the unsorted data and how partition will work? So basically, partitioning does not give you this comfort of indexing. Here, indexing you will have to do manually, meaning you will have to create your own partitions by yourself. All right, that is what the partitioning is about. You manually created these partitions, and it doesn't do it automatically for you. Okay, now, all right. Okay, rest of the questions are answered. Good. It is just for our reference that we create. No, it's not for our reference. We tell Hive that, hey, please create these separate partitions for this separate data, so that when you are querying only a part of data, you will get really fast results. Imagine that if you have one file spread across thousands of blocks. Okay, if it is spread across thousands of blocks, then accessing one block as opposed to 1,000 blocks will have a different turnaround time. Okay, it'll be really faster. No, Hive does not handle input splits, or Hive does not handle the blocks. That all is handled by HDFS. Hive lives with the very simple rules. You created a partition or using a column called qualification, and so Hive will create. Just a second. Hello, and is it breaking still? Hi, is it breaking? Okay, not clear enough. All right. Uh, all right, just give me a second. Hello. All right, can you hear me clearly, or is it worse than the earlier? Okay, not going through. Hi, can you hear me? Hello. 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 Yeah. Am I audible to you? Okay, so are you able to hear me now? All right. I'm assuming that you are not able to hear me properly. Okay, so let's just go get back to what we were. All right. All right. So, hi. If you are able to hear me, please write in the chat window. Hi. Uh, is it okay now? Is it bad, worse, or
Hello, hello, Sandeep.
yeah, yeah? Come again? Yeah. Let me unmute Roshan. Yes. You were saying something? Hello.
Hello,
Yeah.
Sandeep. We are able to hear you properly, but your screen is frozen.
Oh, my screen is frozen. Okay. And now, okay, he's not reading.
Yeah,
See,
can you go to the presentation? Maybe. Yeah, I can see the mouse moving. Yeah, cursor moving. Good.
now you can see the partitions.
Not yet. Yeah, now we can see the partitions. Yes, we can see horizontal partition slides. Yep.
Okay. Okay. All right. Good then. Good. Great. Oh, actually, the chats were not visible for me for quite some time. All right. So now you can see this. Okay. Okay. All right. So there are these two strange issues that have started. One is exactly at 10 o'clock, the voice becomes unclear, and after in the middle, the recording becomes, uh, I mean, because of probably the recording, the slides start freezing. Okay. All right. So let's continue what we were talking about. All right. Maybe there is some culprit nearby. Hi. Yeah. Okay. So Sham is saying perhaps, okay. My understanding is Hive provides an easy interface layer and internally create MapReduce code. Is this right? That is correct. Yes. So if it is right, then it has to write scripts explaining what input splits need to be created. So yes, it basically uses the same set of mm things what we were doing in case of MapReduce. So not necessarily. It'll be creating itself the input splits. Input split creation will be more or less the duty of Hadoop, but it does provide its own input split reader. All right. Okay. Now going ahead, going ahead. First is that renaming a table, just like your standard database operations, you can rename the tables. Okay. Like alter table, log underscore messages rename to log messages. Similarly, changing columns, alter table log messages, change this column, change column HMS, and basically this into this, and data type is int. All right. So we can alter the table just like normal SQL to do this. Okay. Now we can also add columns into existing table. Similarly, we can also delete a partition or add a partition into an existing table. Okay. The next concept which is important in case of a Hive is your bucketing. So after some time, it was realized that the sorting by default in Hive is not much optimized. So yeah, we can drop a partition, we can create new set of partition, but the data reorganization will have to be done by you. Okay, Hive will not do any data reorganization. You have to tell specifically that this data goes into this partition, this data goes into that partition. Okay. So I'm answering to Prithvi's question, can we alter the existing partitions? All right. Now, coming back to the bucketing. So bucketing is a strategy of dividing the sorting. Okay. All right. So, okay. Yeah. So is it any better or is it worse, Santosh? All right. Let's see. Let's see for some more time. Otherwise, we'll figure out some other way. Okay. And probably I've tried with 3 internet connections, but none of them is working properly. Just okay. I don't have these kind of problems in the evening session, and it's only this 1 hour. All right. So one of the question was, is there a way to find who is using our database currently? Oh, this I haven't checked this. So is there a way to find who is using our database currently? So there would be some way to check that, but I'm not sure. I haven't. you, what is the command in SQL generally? Oracle. Okay, I'll have to find that out. Let me make a note of it. So in SP, it will be more like Oracle. Yeah, I'll have to find that out in SQL. I'm not sure about that. Okay. So when it comes to sorting, the standard order by was not doing the proper job. Standard order by of SQL could not do a proper sorting. It did give a result, but order by always did everything on a single machine. That's when the bucketing comes into play, because it's not really possible to do sorting on a single machine, because sorting is probably the most expensive operation, and it does not make sense to do sorting on a single machine. The whole purpose of MapReduce is lost if you are doing sorting on one machine, and therefore the bucketing was created. All right, so basically, instead of using normal sorted by, okay, so we basically uh, create clusters, and basically we say that cluster by user ID and sort by view time into 32 buckets. Okay, so we can also say simply that like this way, it will basically distribute our work into 32 buckets, and then so we are saying cluster by user ID, and then each cluster should be sorted by view time and into multiple kinds of buckets. Okay, multiple buckets. This way, the purpose of the objective of bucketing is to distribute load amongst multiple computers. Okay, that is the purpose of bucketing. We'll come back to this again in the end. All right. All right. So the other kind of tables, so far we talked about managed tables, internal tables, when wherever we had to create a table date, and if you drop the table, the data disappears. So the only difference between internal and external is the, okay, Santosh, we will come to that very quickly. All right, don't worry. Yeah, we'll come back to, because that slide is little misplaced. Now, right. Now we have something called external table, similar to your normal tables. The only difference is if you drop this location where this data is going to reside will live happily. It won't delete that data. Okay. As a general thumb rule, when you are creating Hive tables, prefer external tables over internal tables. Or I mean, to be very specific, just follow these small thumb rules. First is, whenever touching data, external data, touching external data, consider using either a view or external table. Okay, views are expensive because every time you are going to say select star from view, it is going to churn the data. Okay, but view does not consume extra space. Okay, view does not consume extra space, while while internal table consumes the extra space. Similarly, external table also does not consume any extra space. Okay, so the general strategy is you start with creating an external table. So let's say we will be doing a sentiment analysis. In the sentiment analysis, the first thing we'll create an external table on the sentiment analysis data. Now, once we have created this external table, we will be creating something called views on top of this table, and the temporary table which we want to keep it as if our own table, they will be normal managed tables, because in case we drop those tables, we are not going to suffer any data loss. Okay, the secondary data or something like derived data goes into managed tables, and external table is whenever we are referring the external data, and a view is for creating complex logic on top of the data. Okay, we keep on creating views 1, views 2, views 3 on top of each other, and when we execute the last one, all of these views execution will happen just like in pig. All right, so the general strategy is whenever you are referring to external data, always create an external table. And whenever you are having a lot of computing logics here and there, which need to have the fresh data all the time, you create views. All right. So the distinction is, I'm hoping the distinction is clear to all of you. No, it's not clear to you. All right. Shyam's question is HDFS stores distributes data in data nodes. On top of this, Hive distributes it even further by creating partition cluster etc. Yes, that is correct. So when we talk about partition cluster, this data is going to be stored anyway into HDFS. So each partition is going to have 3 replica copies. Yeah. Okay. So there are nice things which you can do with external table. You can load a data from S3. Say for example, you are looking for to churn the wiki data, Wikipedia data, and this data is given by, say, Amazon is hosting this data, and you can access this data at a very minimal charges from Amazon. Okay, so this particular data which is available from Amazon will keep on updating from time to time, and you don't have the bandwidth to keep on storing this data, and you want to refer directly from Amazon's place, right? Specifically when your MapReduce and Hive is also running on Amazon's EC2 cluster. So it will make a lot of business sense to directly refer to that data from your Hive rather than you keep on copying the data every day. Okay. So in those cases, you can create an external table that points to Hive in S3, and then you keep on creating the various kinds of logic on top of this external table. Like in this case, it is mini wiki stats. All right, it will make a lot of sense for us to load that kind of data directly from Amazon. Okay, And similar to the managed tables, an external table can also be partitioned. All right. So we can create something like create external table if does not exist, and then we can say that this table is going to have three more columns which are partition columns, and later on we can start inserting data into this table. Also, you can what I mean by inserting, by adding partition to it. Okay, by adding partition to it. So we can say that one of my partition where year equals to 2012, month is 1, day is 2, this is the file location. And we can also add one more partition saying year is equals to 2011, month equals to 12, and for this particular partition you can have the data from our S3. Okay, so effectively none of this data is local, and the complexity of loading data from S3 and HDFS is completely hidden from the end user. They just have to say select star from log messages where this equals to this, and we can keep on churning the data. We can say select star from log messages where year equals 2011. In case we do that, the data is going to come from this place. Okay, the data is going to come from this place. All right, now that is the benefit of external partition. So Santosh's question is, instead of having extra columns as partition, can we choose existing columns as partition? The answer is no. Okay, the answer is no. You will have to remove those columns from the existing table and then create that partition. All right, so that's a little bit of uh, the grammar issues. Okay, so as a quick recap of what we talked about these data sets. Okay, so each table has got some location of the data, whether local or somewhere else. By default, that table, if you do not specify this location and it's an internal table, then the data goes into apps, hive, and warehouse, this particular folder. If you do not like this location, you can override that location by using the location clause as part of our query. The fourth point is, if you are loading data which is local, which is not on HDFS, data gets copied. In case in case you are loading data into a table from HDFS, data gets moved. And this is true for internal table or external table. If you are loading the data from HDFS, the data gets moved. Okay, dropping managed table or internal table deletes our data in at that location. Dropping external table does not touch the location data. Even if you have imported this data, even then external table dropping does not touch the data. Okay, metadata is stored on relational database, which is Hive store. That was a little quick recap. All right, also exactly like standard SQL, it provides you all sorts of really useful methods, such as select. We can say we can access the complex data type. If you remember earlier, when we were defining the data, we've defined some a complex data type, like here you can see create table employees, where we had a hash map. Okay, we had a hash map. Okay, so we can access the hash map and do exactly the way. These are called projections. This portion is called projection. All right, this is called projections. And all right, so we can do all sorts of projections. Even we can call the function, we can do even the complex multiplication like this, complex expressions like this in the select clauses. This is standard SQL kind of clauses. Similarly, we can also have standard aggregations. We can say things like select count star average this from employees. These are standard aggregation, but if you notice these functions here, things like count star. In count star, you can do this if you have to write your own map reduce, and employees is one plain text file, and you are trying to just count number of records. We don't really require an reduce. We don't require sorting or even summation. Okay, even summation of salary, right? We don't really require sorting. And in such cases, we can say that do this aggregation on the map side itself. So those kind of minor improvement performances is provided by Hive to us in order to churn our data, because we know our data, we know exactly what we are trying to do. So if we say do it on the map side itself, it will do it on the map side. So here we are not counting or doing average in case of group by. We are not doing it on groups. Had it been, department, and then count all the people in the department, compute their average salary, then you are right. Then we'll have to group this table by departments. Okay. I'm answering Santosh's question that for average or sum, do we need group by? Okay. So here we are saying, give me counts of all the records. For counting, you don't require map side, reduce side, reduce side operations. Okay. So that's where you can tell Hive that try to do things on the map side itself if possible. Okay. So in the map phase itself, it will execute these functions and will not execute reduce. Okay. Now next question is that views, we can create views on top of any table. Okay. Say for example, this is our one query which says select some columns from my table, left outer join with another table on this particular parameter. So we are joining T and map where we want the we want the fields from left hand side as much as possible, all of the fields, but on the right hand side only the matching fields, and based on this parameter. So if time zone, for some time zone does not exist in the right hand side, which is on the time zone map, still those time zones should go out. So the overall intention is that we have got this complex enough query. Okay, this is decent amount of joins. Now we have to do it again and again in order to reduce the complexity. If we are having group by statement, then do something else, then do something else, then creating a single query makes it fairly complex to I mean, if you make this kind of queries, it will make it fair amount of complex to solve these kind of problems. I'll show you the full query and you will realize that it would be very, very difficult if four such queries are joined together. Okay, so that's where the views come into picture. We say that our tweets underscore clean is the representation of this data. So every time we say tweets underscore clean, select star from tweets underscore clean, it is going to execute this logic. All right, it is going to execute that logic. So select id comma country from tweets clean, which is id comma country. It will give you exactly, it will run this query on this table internally using MapReduce. All right. Now at times you have to do custom functions just like in pig. You can also do custom here. Say for example, we want to do create a function called lower. We can create using this kind of method where you create a class lower, extend the base one, and then implement a function called evaluate. So for each function, you have to create a class. All right. You have to create a class for each function. Any questions here? So let's say, give me something function. Say we are trying to create standard deviation. Let's say we want to create standard deviation. So what will we do? We will say we will create some package. Okay, this is again some package. This is up to us. What package do we want? Then we will import all the data, all the packages which are required for us. Then we say public final class. Final is again optional. We can say public class, and we say standard deviation extends what? UDF extends. We can say extends UDF and then angle bracket, and then we can say public text evaluate, and we say final text as. And basically what is it that we are trying to do is we are trying to create our own function. Okay, so we are trying to create a function called SD, and this is what it is. All right, sounds good to you? Here we are trying to create a function called lower. All we did was we took this is the input on which we'll be applying. So we said s.toString to lowercase. We used a Java function and then returned it. Okay, return that new value as text. All right. Now, after you have created this kind of class, what you do is you basically create your jar, and then this is something which you need to note. We say add jar your.jar, whatever jar you have created, and this jar has to be in the local file system. It doesn't have to be in HDFS. And then you can start using your function like this. Okay, I'll show you. Uh, okay, now let's say the example, the whole project is actually available here, and so Hive UDF steps are there. Project is available here. You can download this project and start manipulating it. All right. So basically, you try to import this same project what we are talking here. So here we have our Hive UDF. Okay, here it is. And here is my project, which basically describes this. It is SG. My project is in SG. So what I can do is I can say export and jar file, and then after doing this I will give it a nice name, Hive UDF, and I'll call it SG and put it in folder and then finish it. And also note the all the libraries are, you require two libraries, Hadoop Common and Hive Exec. That's all. Okay. Once that is done, you can upload this. I'm on the my local laptop. I'm on the laptop now. So I'm copying SCP using SCP. You can use WinSCP, and we can say Hive UDF SG, and we can say student, copy it to sgiri folder. Can say student hadoop 1.nobigdata.com and sgiri. It's it's copying it to my folder. Okay. It looks like it's big file. All right. Once it is done, we can simply say, we can come here and say add jar, and this is our jar. This does not exist because it is getting uploaded. Oh wow, this is more than 10 MB. This is 15 MB actually. Strange. 16 MB. Wow. All right. So once you are done, then you will be doing create temporary function to sg.lower, and after that we'll be just trying to call this mylower. I just gave this name to our function, and then we can keep on using it. Is it done? 72% done. Okay, you can see a more detailed example here in case you want to customize further any of the operations provided by Hive. All right, any questions still here? So here there's a uh, further deeper example for customizing Hive. All right, now let's have a look at it, what's going on. All right. And once that is done, we'll be saying add jar, my jar, and yeah, it's done now. Okay, so it says it doesn't exist because it is in our folder, I think. So jar has been added. We said add jar and give the relative path. Inside asgiri folder, this is the jar. Now the next step is to create a function on top of this one. It did. And then we can simply say things like this. Okay. myLower is our function which we just defined at myLower, and then are executing it. Okay. This way, this example proves that it is possible to customize Hive with Java. All right. Now, in case your data is in JSON, you can use these libraries called JSON Survey binaries. So the way we customize the function here, we can also customize the the way Hive reads the data. We can customize that function by using these libraries. So you download the JSON library, and then once you have downloaded, put it on the local folder, and then you say after you get into the Hive command line, you say add jar your jar name, and afterwards you will be able to create your table from JSON data by informing Hive that, hey, I am trying to use this particular row format where I say that my serializer deserializer is this particular class. This is the class which comes bundled in this jar. Okay, so does it make sense? So you download this library and you want to load a JSON data, you can load JSON data like this. Sounds good to you? All right. Now this way you can load any kind of data. Okay, XML data, JSON data. There are many kind of serializer, deserializer. Serde is serializer, D is deserializer. There are many kind of serializer, deserializer available. All you need to do is download the jar, add the jar, and then you specify the row format by telling Hive that this is your serializer, deserializer. That will convert any data into tabular format. All right. So now you can see that this has become uppercase, although it is ideally it was supposed to lowercase, but since we have written that way our function that it converts it into uppercase, it converted into uppercase. Okay, sounds good to you, that because that is our function and that our function is being executed. Okay, that's the whole purpose of it. Now, order by X, as we were talking about, guarantees global ordering. Okay, it guarantees that there will be a global ordering. Does this by pushing all the data through one reducer. So this sounds very insanely stupid when we talk about humongous data, right? This is insane that we are trying to pass the whole data through one reducer. Okay, so you always have one sorted file as the output because there is only one reducer. Now, this is fairly unacceptable for the big data. And that's when the sort by X comes into play. Okay, sort by X can specify a number of reducers where it orders the data on each of the n number of reducers, and each reducers get can receive overlapping data ranges, and you might end up so first after this order by, somebody tried to invent sort by, which basically divided into n reducers. But if your data is overlapping, say one reducer is getting some keys which are some keys between who there are another keys, but those are in another reducer, right? Meaning, in case you just combine the output of reducers, you will not get sorted data. In those cases, sort by does not work really well. So what people did was they then wrote distribute by X. So the distribute by X make sure that the data is non-overlapping. Okay, so that if you combine sort by and distribute by, then you'll get a perfect sorting. Okay, so that's when cluster by comes into play. It makes sure that all n reducers, whatever reducers it is going for, they all get non-overlapping ranges of the data, and each of the section is well sorted, and basically it's equivalent to distribute by X and sort by X. Okay, you might end up with n or more sorted file with non-overlapping ranges. Okay, which means if you just concatenate all these files, your data will be sorted. Okay, whenever you say cluster by, it's equivalent to the distribute by plus order by. Okay. So cluster by effectively is a powerful version of order by. Order by did sorting for you. Order by did sorting for you, but only through one reducer. And that's where the cluster by says that I will sort your data using multiple reducers. All right. Now let me actually remove that slide which we've talked about earlier before this. Okay. And yeah, so we can basically, whenever we are saying cluster by, right? This is not required actually. This is not required. It's up to you. If you are well confident that after you cluster your data by a particular field, if the data ranges are you going to get are mutually exclusive, then you can do a further order by. Okay, but it's not required. Okay. Now this is called bucketing. Let me bring it down to here because okay. All right, so now let's try to do a small exercise. Let's create something like we call it 21 fab, and this is our data. We will upload the data into this table. Okay, so this data contains user ID, movie ID, rating, and Unix time. This is our table we are trying to create. Okay, so let's create that table. All right, now we have created this table. If we say select star, select star from oh, select star from, okay, there is nothing in this table right now. So next step is we download this data, and we talked about two things here. Wget is the command. If you give that command any URL, it will download that file. If you say wget minus r, it will recursively download the whole file, whole website. Okay, and this exclamation here will basically download will basically execute this command. Okay, so I have already downloaded this file. So here I have already downloaded this file in Asgiri. Okay, so there it must be somewhere. Yeah, you can see ml 1 million, ml 100k, right? So basically what is this file? This file is a tab separated ratings of various movies, user ID, movie ID, ratings. That's what is this file. I will you know I'm let me just go to my folder as Giri. Okay, so this is my folder. In this you will see this file 100k. These are 100,000 ratings of all the movies. Okay, out of this we are going to pick up u.data file, and what is there in this data file you can see clearly here. Okay, this is our data file. It has movie id, user id. First one is user id, then movie id, then ratings, then timestamp. All right, then what we can do is we basically load this data into the table. Okay, already, but before we do this we will put local. And what is my folder name? My folder name is this. Let me just put this folder name. So I've downloaded this zip file, I unzipped it, and this is my local folder, and that's what I'm going to specify in here. Okay, now we created a table, downloaded the zip file, unzipped it, and now we are trying to load. We say load data local in this particular path, overwrite into our table, right? And we go to our Hive, and all right, now you can see our table most likely will have select star from, what was the table name? This one. Limit 100. Okay, so you can see we could quickly see top 100 records by using SQL. Okay, now since we have our table ready, we can do all sorts of magic, whatever we want. Okay, so let's say we want to find out for each movie ID, for each user ID, how many movies the person is rating. So user ID, select user ID, comma, count movie IDs, okay, from my data, and we say group by user ID, right? What exactly we are trying to do? We are trying to group our table by user ID and count how many movies each user has rated. All right, or as an assignment, you repeat all of these steps. Create your own database. As an assignment, create your own database, create your own table, download this data, unzip it, and then load the data into the table. After that, try creating your own statistics. Okay. For example, how much is the standard deviation of each of the user, or what is the average rating each user is giving? Okay, for each user, for each movie, how many users have rated it? Okay, that way you can figure out which movie is more popular than the other. All right. Furthermore, if you want more insights into your data, you can basically copy the other file also. In the same folder, you will observe that there are movie details, other movie details are there. If you see this folder here, if you open up, something called, there is a file u5 base udata, and then you have u1 test, u2 test, u3 test, and there are all sorts of so this is a Perl script. This is another one. So this is our data. There was one more file in this folder which I think has been deleted. All right. So this is genre of the movies. This is users. These many users are there. This is movies. And what is this file name? u.item. u.item. It contains all the names of the movies. Okay. You can further join your data, whatever results you get, with this, and can figure out how is the distribution of various things. Okay. And this is the characteristics of the users, whether it's a male, what's the occupation, what date they give. Okay, now, so this way we were able to, you can see the results of our query. Each user, this user, can you believe that there are people who have rated 270 movies? Okay, we could do further order by onto this kind of data, saying order by, you can say, if you create a view on top of it, you can say uh, order by X, okay? And then the ratings will be sorted by that particular column. Sounds good? So as an exercise, for each movie, how many users have voted it? That is your assignment. For movies having more than 13 ratings, what is the average rating? Okay? So try to write these two queries and send me in an email. I have already reviewed some of your assignments. I'll send out the details. Okay. And basically try to repeat the same thing along with writing queries for these two assignments. Okay. Use views, use external table, whatever you want to use, but get this result. All right. Is everyone okay with this? All right, great. So if you have, you should give it a shot, and you will be happy about the fact that with the same set of queries and logic, you will be able to do it on terabytes of data without worrying about internal complexities. Okay. So try doing it. Let me know if you get stuck somewhere. Just drop me an email if you get stuck somewhere. I may not be reply you in a very big explanatory form, but I'll give you hints. I'll give you a quick next step so that you get unblocked. Okay. Sounds good to you? All right. Thank you, Santosh. See you tomorrow at the same time. All right. Bye bye. See you.